This is our lesson on multiple representations for lines in linear situations. When we're talking about multiple representations, we're looking for four different things. One of them is, can you come up with the equation for the line? Another one is, can you graph the line? Third one, can you write a table for the line? And a fourth one, can you come up with a situation for the line? The situation may be a number of different things. One of them may be a tile pattern, like the one shown here. So we're going to start with this situation. Now, I have figures 1, 2, and 3 drawn in blue. We've started with those three figures. And we want to look at how it's growing each time. We can see that growth by the squares that I've highlighted in red. From figure 1 to figure 2, we added this square on the bottom left, and we added these two squares in the top. If we go from figure 2 to figure 3, we can see that the pattern continues. We added another square to the bottom left, and we added two more to the top. Those three tiles that we're adding each time, that's our growth. So when we write our equation, that's going to be our m value. That's our slope. We also want to draw figure 0 and figure 4. So to get figure 4, we just continue the pattern. We put one more on the bottom left and two more onto the top. To get figure 0, we have to work backwards. Think about how we undo things. Well, we've been adding one to the bottom left, so we're going to take that one away. And we've been adding two to the top, so we're going to take those two away. If we take that one away and those two away, we're left with just the one in the middle. So figure 0 only has one tile. That's our starting value. So 1 is going to be our b value when we write our equation. So we can see from the tile pattern what the m value and what the b value are going to be for our equation. We can also count the tiles and make a table. So here's the table. We have figure number and number of tiles. All we have to do is count up the number of tiles in each figure number. So we can go from the situation to the rule, or from the situation to the table. We could go from the situation to the graph also. I've redrawn the table on this slide here, and from the table we could go back to the situation. If you're given a table, you could make a situation, draw some tile patterns that fit the description. May not be the same tile patterns I've drawn, but you should be able to draw a figure that grows like this. And from the table, we can graph these points, and we get a line on our graph. Or we can look at each one of these points and we can figure out the equation. Our starting value is when x is 0. So our starting value is 1. So that's our b value. Our slope is how much it grows each time. Notice from 1 to 4, it went up by 3. From 4 to 7, it went up by 3. 7 to 10, up by 3. It's going to continue that same growth. So that's our slope. That's our m value, and we can get our equation y equals 3x plus 1. So we can go from the table to the situation, from the table to the graph, table to the equation. We should also be able to go from the graph to the situation. If you're given a graph like this, you should be able to look at the specific points. Say, well, figure 0 has 1 tile, figure 1 has 4 tiles, figure 2 has 7 tiles. How can I draw a tile pattern that matches that? Or we could go from the graph back to the table. If we look at each point on the graph, plug it back into the table, we get this table up here. We can also go from the graph to the rule. If we look at our graph, the b value is where it starts. Well, it starts at 1. The slope, remember we drew slope triangles to find the slope. We're going up 3 and over 1 to get our slope. 3 over 1 is 3. And we have our equation y equals 3x plus 1. We should also be able to go from our equation to the situation. If we know that this is our equation, we know that we're going to start with 1 tile in figure 0. And then we're going to increase by 3 tiles for each new figure number. So you should be able to draw that. We should be able to go from the equation to the table. Figure 0 is going to have 1 tile. Figure 1, we can just plug 1 in for x. 3 times 1 is 3, plus 1 is 4. Figure 2, 3 times 2 is 6, plus 1 is 7. So we can go from the equation to the table. And we should also be able to go from the equation to the graph. We're starting at 1. And we're increasing by 3 each time. So we can go up 3 over 1, up 3 over 1, up 3 over 1, up 3 over 1. And we get each point on our graph. So we have a situation, a table, a graph, and an equation, and you should be able to move from one to the other.